The way bulk materials behave depends very much on the internal friction characteristics and the cohesion characteristics of the bulk material, or the bulk solids as we call them. These particular products are able to transmit friction and shear stresses under static conditions. In that way they're quite different to liquids. Bulk materials come in a range of sizes, and commonly we think of them as grains that we've just seen, or in the case of mining we think of them as powders, ranging from micron size right up to the large size, where on the right hand side here you see 2.3 metres. That's a lump, that's a feeder feeding bauxite ore into a primary crusher. But occasionally the rogue particle gets rather big, as shown by this one here. That's a piece of iron ore. In Western Australia they refer to them as bundies. Occasionally we have other materials such as waste material. It's hardly conventional in its form, and you can see that there's such a wide range of material types that characterising is quite a major study, and to the uninitiated it's often misunderstood. There was always a school of thought that maybe the angle of repose was a measure of internal friction. That's certainly not the case, because in reality, if we measure the angle of repose, say for wheat, you might get an angle of 32, 33 degrees, or if you measured it, say for coal, you might get 38 degrees, or iron ore 38. So two vastly different material, one free-flowing, the other one quite cohesive, yet the angle of repose doesn't change much. If this is a pile of dry wheat or even dry sand, perfectly free-flowing, then stack it up. This angle here might be about 32, 33 degrees. But if we sort of dig into that from the side, the material will slip down and continue to slide down at the same angle of repose. On the other hand, if you take a sample of iron ore or coal, you might stack it out on load-out like this, but you can actually dig into it and undercut it, because internally the bulk strength and cohesion is enabling that to have stable cavities like this. Quite dangerous, of course, to be near them, because you never know when these stable structures will collapse. Thank you for listening or viewing, and we'll see you next time.